Put everything on one coordinate plane.
Everything?
One coordinate plane. So you have an X and Y axis. You label it. You plot your point.
Wait, 8? I don't go to 8. I went to 5.
Well, three more. Three more will get you there.
That's tough. No, I said it was hard, dude. I don't like that.
So, did you label your X and Y axis? Did you put a little X by your X one and a little Y by your Y one? Go ahead and do it if you didn't. Go ahead and label.
Are you kidding me?
Make sure you have like some sort of number indicating the intervals at which your lines change. So I have 5 dashes and a 5 here, which will tell anybody reading my graph that my intervals go by 1. So you need to put a number in the positive and negative. You don't have to label them all, but put one number that will tell the person reading your graph what your intervals change by. Fine. Yeah, that's good too. Label everyone. That's fine too. This is. Oh, I should have changed these. Silly. A. B. C. D. I'm gonna change my E to D, you guys.
Oh, I didn't even see the label.
I'm gonna change mine. I don't know.
I just put a dash on top of it.
I'm gonna call this one E.
I thought that's what the
F. B.
I'm so sad it's already gone.
That's better. Okay, here's letter E. Here's letter F. Here's letter
You don't need that pepper.
G. Here's letter H.
You don't even know what it is. No, it's not. You don't. Yes.
Go ahead and write this statement out.
There you have. That's fair. We got some.
Shorthand. The points in number 1 are called. Write it out. Who knows it? Libby, you know it?
Yes.
What's it called?
points in number
They're
one.
called x-axis.
No, not x-axis.
X coordinate.
No.
Wait, they're called.
Yeah. Okay. Like clearly something's going on. These points aren't just like willy nilly anywhere.
Why would they be functional?
So the points in number one, they're all these blue points. What are those blue points called? They're on the x-axis. Lauren? X values. That's not it. No.
Ordered pairs. Domains. Domain. Domain.
Let me write it. I'm just gonna write it for you.
Probably.
Maybe you haven't heard
it before.
X integers. I already know
Interval.
It wasn't.
Intercept.
Oh, intercept.
Oh,
it.
interior.
Oh, you did say an I word. I didn't even hear it though. I didn't hear integers. That's very close.
Don't tell me we're learning X intercepts and Y intercepts.
I did. I said that. Under my breath. Alright.
You don't tell me we're X intercept.
Why are we learning? I don't remember half of this stuff.
Please don't tell me we're learning Y intercept form and
Please
stuff
don't tell me
like
this is
that.
going slow form.
Yeah, please.
No.
Chapter 3.
I hate that one.
Chapter 3 is graphing lines.
Wait, graphing lines is not bad, but I want to do X and Y intercept form and stuff like that.
Yeah, it's happening. That's what we're doing.
It's so complicated.
It's like, it's so bad. And then you have standard form and then
It doesn't even make sense.
point slope form, slope form. It's terrible. Yeah, I know, but it sucks.
Okay, last part of this, and then we'll move on. All x-intercepts have what? Let's make a statement.
X values. Duh.
What do they all have in common? What do the points in number one all have in common?
They're on the X coordinates.
Zeros. They all have zeros. Yes, every single one. Look. That's not a coincidence, it's a fact. These are facts. All x-intercepts have what? Specifically what? Zero y value. Alright, look at it up. All y-intercepts. Boom. All y-intercepts have zero x values. Alright, I'm gonna show you a short video clip. Please write down the information in the video.
To me.
I'm not changing that. Smells like carbon.
It's not. It smells like
water slides?
Smells like that.
Smell.
Nothing smells.
Are you quiet? Write the facts down.
What?
Let's try again.
Guys, write the facts down, guys.
Can you
What are the two
Before 6 p.m. and 20 after 6 p.m. Just remember the numbers. You don't have to write it down.
No, write it down, Tony.
Well, to
Keep going. Keep your bowels rolling. Same paper. Keep it rolling. Water park. Water park. Problem.
Target.
Yeah, because more people come before 6. That's why. I just scratched it.
Yeah, that's a lot of money.
Only $20 after 6 p.m.
I'm at 6:01. Well, I'm telling you right now.
Ready.
I thought I just said I had nothing else.
50 before, 20 after. Let's just say that.
That's bad. Why would they charge more before? No one wants to go to water park.
Yeah, no one's gonna go after, like, you got a soccer game, you don't have time. Oh, it's only $20. Let's just go real quick.
Shoot, I do it. There's no way I'm running. Oh, okay. Adventure Islands is the OG. Adventure Islands is the OG to go to. You already know that.
So let's just go ahead and answer this question.
One day.
You want an answer? Okay, so how are we gonna? Anybody have any idea how we're gonna solve this? We're gonna need to write an equation.
There's no way it's X and Y.
So it says how many emissions may have been sold. So may is kind of a key word here.
About.
May indicates that there's more than one right answer. Does it say more or more? I mean, Jake, if you really need to go, you go ahead, okay? Okay. More than one answer. Okay, so let's talk about. Okay, yeah, we don't. So what this question is really asking you is, can you come up with one possible solution? There's actually infinite. There's actually infinite answers to this question. How many emissions may have been sold if they took in 20,000? So it was $50 before and $20 after. In the equation that's going to come up with all of the possibilities would be X represents before 6 p.m. I'm going to write that to find my variable.
What time do the cars leave?
We're going to call Y after 6 p.m.
Oh yeah, what time is the park? Yeah. It'll be so like 6 p.m. 6 a.m.
It starts
So,
before 6 p.m.
$50 times the number of people who bought a ticket before 6 p.m. plus $20 times the number of people who bought a ticket after 6 p.m. equals $20,000 coming into the water park. This is called a standard form linear equation. So, can anybody now, using a calculator, tell me one possibility for this water park? Mikhail. 400 tickets before 6. Is this true? Is 400 times 50 2,000? Nailed it. You got it. Yeah, I'm looking at 20,000. I'm gonna go with 40.
Dude, I don't like this. I don't like it then. This sandwich was the best part of the day.
Yeah, 40 times 50. Let's say nobody comes after 6. The water park made $20,000 after. 1,000 tickets after 6. You guys agree 1,000 times 20 would give you a $20,000 income. You got another one? Okay.
Wait, was it 40?
Yeah.
Oh, okay. So I got 30 tickets before 6, which means that is how many? 150 or 15,000. But
Okay.
can we put 20 under that? Oh.
What?
Well, we need what? 5,000
Oh wait,
more.
4 times 20 something.
What if we had 10 of these? And that's 500.
So is it 200? No.
What if we had 20 of these?
What have we got?
What if we had 20 of these?
Yeah.
20 of
That
them. Go with that,
10,000,
Jake.
right?
Yeah, 20 would be 10,000.
Okay, so 10,000 and then we would have
500. Yeah.
yeah
50.
500. No 50.
Nice job. You got it. Alright, so these actually zero.
Yeah.
Okay. So these actually represent ordered pairs on the line of this on the graph of this line. So it's 40 tickets before and 0 tickets after. What's this called? Y0 is the x-intercept. It's
I can't. It's too dark.
yeah. Let's turn the lights back on. I agree.
No,
I can't
like
either.
10 feet away. Oh, now I can see it. Oh my god. Glasses. Just get glasses. I'm sorry that my eyesight is how I was born. You make me mad. I knew you didn't see whatever. I was just saying to you guys from sleeping in class. I want to sleep in class. Yeah, man.
I'm getting my zeros wrong. This is 400.
This is a hard lesson. I don't want to sleep.
And then so our other one would be
Yeah, does that mean 200 also? Yeah.
okay. Thank you. So 0, 1,000. All right. So let's make a quick graph of this situation.
You said you were good. So wait. Wait.
So Benjamin, how would I label my x-axis with this being our info? By hundreds, yes. But what does the x represent? Yes, tickets before. And so the y-axis represents tickets after 6. No, not in a standard form. If it was y equals mx plus b, y typically represents cost. But here, but this is standard form.
I don't like the easiest one was slope form.
Okay, so we have 400 comma 0. We have 1,000 comma 0. Graph it. Any point in here, the blue line represents the water park making $20,000. So any combination of points on here is the water park making $20,000. So it's 200, 500 on here. That's pretty close. Long story short, we're starting chapter 3 and it's on X and Y intercepts.
That's so great.
Start graphing.
That's how great that is.
I'm giving you a note handout for you to take notes on moving forward here. So take one past your back. This is for you to write on your sheet.
I don't like it.
Yeah.
That is the thought on. It's not.
It's on 200, 500. It's just not
I
perfect.
thought the like thought on the bottom.
His 400 tickets here.
Oh,
It's 20 bucks.
And then it's 1,000.
You see it?
You said you could hold it, so hold it. Thank you.
When you get your handout, begin reading it.
Oh, stretching my. Wait.
I could, fell asleep. I would have gone, but I fell asleep.
Actually, this time.
Too early for that. We got 6 kids. Oh, heck no.
And then what happens if we let a man slip? We're gonna get killed.
What happens if you guys need to scramble? Yeah, you do.
They're gonna figure everything out.
You at least have to run. Will. Will. You at least have to run Tom Brady's speed. Maybe.
That looks slow.
I know. Well, he's like fast to you. He runs like a 5. So that's something. I think he's only a 5. He's a 5. I gotta check it out. He hasn't done one this year yet. No, he's not. Wow.
Alright, a linear function written in standard form has the x, ax plus by equals c. X and y are on the same side of the equal sign. That's called a linear function. You have two unknown variables, x and y, and the possibilities when there's two unknown are endless, and that's why when you have an equation with x and y, it's this like all of these ordered pairs together. A has to be greater than 0. A, B, and C are integers. The graph of a linear function is a line. The graph has a y-intercept where it crosses the y-axis and an x-intercept where it crosses the x-axis. Linear models are often used to describe real situations such as water parks. All right, Anna is flying an airplane on its final descent. What does descent mean? Going down. The table shows the function relating the height of the plane above the ground and the time the plane has been descending. Find the x and y intercepts. Explain how you found each intercept. Go ahead. Answer it. Maybe you want to graph it first. Maybe let's just graph it first. I'm gonna put my ordered pairs down. I see a pattern here. Yeah, what's this?
I do too. It's one straight line, but negativity.
How much is it going down every 2 minutes? It's going 12 every 2 minutes. So this plane is descending 6 feet per second. I was gonna say per minute. That's like really slow. It's like a glider. 6 feet a second. Like it's hitting the ground. How long did it take to hit the ground, Benjamin? 8 seconds. So I mean, it was pretty high, and then that's like your drone you got for Christmas. Boom, hit the ground. Number. All right, I'm gonna connect these dots. This is the airplane going down. Anybody ready to answer letter A? Will, you have an answer for letter A? Can you identify the x-intercept Aiden? H0. Let's highlight it and label it. Oh, true. You may have a highlighter in your backpack. Aiden, you told us that. How did you figure out that this was the x-intercept? Love it, love it. All right, let's kick this to somebody else. Dominic. Dominic's so excited about the y-intercept. He's texting about it to somebody. What's the y-intercept? He does. I want an exact number. That is the intercept. Will, we'll kick it to you. 048. Oh, you can't read this color, Tony. So don't just, you know what, call me out every time. No, but why do you use that color? Nobody can read it. Just like that. This is your y-intercept. Go ahead and label it. And write about it. Think about it. Have a dream about y-intercepts. 048. Will, how did you figure out it was 048? Point on y-axis. Because the x is 0. Right? Zeros are intercepts. All right, so letter B we have done. We have plotted it. Mikhail, can you interpret what the x-intercept represents? I love this word interpret. Ooh, I love what you said, the starting height. But is the starting height the x-intercept? So let's interpret the x-intercept. Maybe you want to box x-intercept. That's what we're explaining. Perfect. I'm with you. I wish I knew. Is this a glider? Is it like a styrofoam dollar store glider? Is it like a drone? It says it's a model. Did anybody race those airplanes like over? They have like remote control.
I was actually
RC planes. Nobody's done that? I thought it was like a thing around here. All right, y-intercept is done. Mikhail already said it. Can anybody else describe what does the y-intercept represent? The height when? Something on 0 feet. Height when it's descending. Well, that all of this is the height when it's descending. Specifically, what's this? The starting height. This is the height when the plane begins descending. So we're really being very picky about the words, right? Like really definitive. This is less math and more kind of like reading comprehension, data analysis. All right, letter D. Does plotting the x and y-intercepts give you sufficient information to graph the function? Yes, but why? If it is yes, then complete their graph. I'm gonna go with yes. Any 2 point. You know what? Doesn't this color? Isn't this pretty bad too? Isn't this hard to see in the back? It's like too fluorescent. Answer no. Create a linear graph. So if you observe that the data is linear, and that means like when we saw it was going down 12 feet every 2 seconds, that means it's a straight line graph. Any 2 points, whether they're in. Do you guys remember what domain represents?
The x values.
Okay, let's just recall that. Domain is a set of x values. What does the domain? So what is the set of x values true for this airplane?
Zero.
So,
Oh, well, 0, 2, 4, 6, 8.
Okay.
Please don't include 0.
All right, Tony is describing what we're seeing in our points: 0, 2, 4, 6, 8. But is the plane descending at 1? Yes. It exists at 3. The plane doesn't jump from 1 second to 2 seconds, 2 seconds to 4 seconds. Like the plane is descending between 0 and 8 seconds. So the domain we could say is between 0 and 8 seconds. And I'm actually going to show that using, I'm going to show that using an inequality. Did I do these fancy brackets with you guys? Did I do these fancy brackets line with you guys ever? Yeah, and domain. So fancy brackets x is between 0 and 8. This is how you show that domain. It goes between 0 and 8. It's not just the points. If you connect the points, it's a full line between 0 and 8. What's that?
What is the line in front of 0?
It's let me write it more neatly here. So it's like this. This is how you like right here. I'm gonna write anything that x is. This is called set notation. So I would In the domain, I would put a Y, a line, and then talk about the domain. Might as well just, I mean range. Might as well just do it. The range is between 0 and 50. I mean, I did. You might as well.
What if one was based?
It's not going to make you less competent.
It's not gonna make you.
It will make you more competent. So the line is like just identifying what we were talking about.
So more like if you want to, you can.
Okay. I'll go with that.
Okay. 'Cause I don't have space.
Okay. All right, let's go ahead and let's skip all the way down to where it says practice, and let's talk about keys. I want you guys to work on this for a minute. You can work on it with the people around you. You can chat about it. Get 1, 2, and 3 done.